Hi everyone. In today's lesson, we're going to talk about another concept of taking derivatives called the product and quotient rule. So the product rule is used when we have two functions being multiplied together and we want to find their derivative. So the rule is we're going to call this guy the first one and we'll call this guy the second one. So the derivative, dy dx, is in regular symbols f of x first times the derivative of the second plus the second times the derivative of the first. So that's what it is in symbols. In words, you can write first times derivative of the second plus second times derivative of the first. All right, so that's the formula for product rule. So I want to find the derivative of this first function here, f of x, if f of x is ln of x e to the x. So what you should notice is that they're attached by multiplication. So if I write it as f of x equals ln of x times e to the x, it might be easier to see that this is a product. So we're just going to call the one that's in the front the first one. You can call that f of x. And then the second one you can call g of x, right? This is your first one. This is your second one. So the formula says if we want to find the derivative, which is going to be first, so f of x times the derivative of the second plus second times the derivative of the first. So I let f of x be ln of x, so I'm just going to put that here. That's f of x. So ln of x times g prime of x, which is the derivative of the second. So we know that the derivative of e to the x is just e to the x. It's the same thing, plus g of x, which is this e to the x again, times f prime of x. And f prime of x is the derivative of the first, derivative of ln. So we should remember that the derivative of ln is simply 1 over x. So it's fine to leave your answer like this, or if you want to simplify it a little bit without everything, we don't need that multiplication dot, and we can put the e to the x over the x if you want. This is perfectly fine as an answer. Okay, so second question, same thing, another practice one. Find dy dx, find the derivative if y equals this. So again, I'm going to separate it. Y equals -4 sine of x times radical x. So that should help you see what the first is and what the second is. So you can call this your f of x or your first. And you can call this your g of x or your second. And we can take our derivative now. So the formula is first times the derivative of the second plus second times derivative of the first. So the first value is -4 sine of x. We're going to multiply that by g prime, which is the derivative of radical x. So we know that radical x is the same thing as x to the 1/2, and the derivative is when we use the power rule. 1/2 in front, keep the base, decrease the power by 1, so you should get -1/2. So here is 1/2 x to the -1/2, and let's keep going, plus g of x. My g of x is my second, so rad x, times the derivative of the first. So the derivative of sine, so let's do sine, cos, sine, cos. Since there's a negative here, we'll say derivative of negative sine, which is negative cos. So -4 cos of x is my derivative. So -4 cos of x. Now, we can clean this up a little bit if we want, but we don't have to. The only thing that I would probably recommend is use parentheses, because if you forgot to put this multiplication dot here, for example, you would probably make this look like radical x minus 4 cos x, and that's not what's happening. You're actually multiplying them together. So if you never want to get a problem wrong, what I would do is put f of x in parentheses, g of x in parentheses, and do this around everything, and it'll always be right. So same thing with this. We could do this, and this, and this, all right? We don't have to simplify it. We'll just leave it like that for purposes of time. And let's just take a look at question number 3. It says, let f be a differentiable function such that f of 2 is 4 and f prime of 2 is 7. If g of x equals this, what is the value of g prime of 2? Well, the first thing you should recognize is that the question is asking for g prime of 2, and they only gave us an original g of x function, so we must take the derivative. So I'm just going to first start by writing down my derivative. So g of x equals x to the third times f of x. So this is my first, this is my second, and we're going to take the derivative, g prime. So remember the product rule, first times the derivative of the second. Well, since the second is given to us as f of x, we can just write the derivative as f prime of x. So first times the derivative of the second plus second times the derivative of the first. Derivative of the first is 3x squared by the power rule. So we've taken the derivative, and now we can answer the question. It's asking to find g prime of 2. So g prime of 2. That means everywhere we see an x, you're going to put in a 2. So 2 to the third times f prime of 2 plus f of 2 times 3 times 2 squared. So g prime of 2. 2 to the third here is 8 times f prime of 2. Well, they gave us that. F prime of 2 is 7. Plus f of 2, well, they gave us that. That's 4. And 3 times 2 squared, 3 times 4 is 12. So g prime of 2 is 8 times 7, which is 56, plus 4 times 12, which is 48. So if you do a little quick math, that is 104. So g prime of 2 equals 104. And that's it. Okay, so let's move on to the quotient rule now. The quotient rule has the name quotient means divide. So when we're dividing two things. So the rule for this one, I like to use a little fun acronym. The bottom we're going to call low, and the top we're going to call high. So high for top, bottom for low. The derivative formula is low times d high. So I'm going to do high prime. That means d high means the derivative of high. So low d high minus high d low all over low squared. So the way I'm saying this, if you want to write it out, is low d high means the derivative, low d high minus high d low all over low squared. That's just a way that we can remember how to take the derivative of a quotient rule. So let's take a look. We're only going to use this when I have two things that I'm dividing, right? So I've got a fraction here. This is my high, this is my low. Let's go ahead and label that. So high and low. So the formula, if we want to write it again, low times d high, so low d high minus high d low all over low squared. So the low literally means that we're going to replace it with the low. So what is the bottom one? 5e to the x. So 5e to the x. And then we're going to multiply that by d high. So d high means look at the high and take the derivative. So we've got sine, cos, negative sine, negative cos. So I need to take the derivative of negative coast. So I look around and it's sine. So sine of x. Then I have high, and all I'm doing is rewriting my high, and then I'm multiplying it by d low. So we need to take the derivative of the low. So remember that if I have 5e to the x, the derivative is just 5e to the x. It's the same thing. So 5e to the x. So there's your low d high minus high d low. I think I have a typo here. I apologize. The formula has a minus. So low d high minus high d low all over the low 5e to the x. That whole thing squared. Now, again, you don't have to simplify it. Just leave it like this. The best thing that you can do, though, really, is these parentheses. That really helps you not get the answer wrong. All right? So we're just about at that 10-minute mark, so I think it would be a good time for you guys to try some on your own, and we can definitely start class by going over these. So why don't you use the quotient rule for number 2 and use the quotient rule for number 3, very similarly how we did the other ones with the product rule on the front page. And we'll start class by going over that tomorrow. All right, have a good night.